Hello students, my name is Hafsa. Hope I am not new to you. We have already taken some Zoom interaction classes. Now we are coming back to this mode of teaching which seems to be better than the previous one, because we will have clear cut understanding of the subject as well as interaction will be efficient. After watching the video of complete class, you may post your feedback as well as if any doubts on our WhatsApp group. Okay. Coming to this mode of teaching, which is the first chapter is atomic structure. We have already seen the introduction of atomic structure in our previous classes. The reason why I am coming back to the same topic is, in the previous method of teaching we have just discussed, in which you put your views as well as I have given my explanation, which seem to be not much in detail. But in this video we are going to discuss in detail about the atomic structure. The question I want to ask you all is, why atomic structure is the first chapter in our chemistry? Because the total syllabus of intermediate in chemistry, both for first year and second year, depends on this chapter, because it is the fundamental concept in chemistry. Without knowing atomic structure, you will not be able to understand any chapter in the syllabus of chemistry, be it in first year or second year. Why so? Because in this chapter we are going to discuss what is the basic component in chemistry, which is atom, electron, proton and neutron, as well as how it will involve, how it will interact with each other to give rise to complex topics which comes further, right? So before starting this chapter, I want to congratulate you by joining in this method of classes organized by Sri Sai Vidya Vikas College, in which I am going to talk about all the chapters in detail. Okay. Let me introduce myself. My name is Hafsa and I am going to teach you chemistry classes, and rest assured, if any doubts are there, you should not be afraid to post it in our WhatsApp group. Okay. Coming back to atomic structure. When we say atomic structure, when you say structure of anything, if you say structure of a building, whatever object structure you are studying, you have to talk about what is the shape of the building, what is present inside the building, how it is arranged and all that. Structure, when you say, everything comes along with it, right? Similarly, even in atomic structure also, everything present inside the atom, how atom looks like, what is present inside the atom, how it is placed, how it is working, how it is surviving inside the atom, everything comes under atomic structure, right? So atomic structure topic, or the question or the reason why atomic structure came is because earlier the scientists used to believe, even in the olden days also, there were many postulates, there were many much studies going on in the field of science, but that was not proved experimentally. Therefore, whatever was proved experimentally, whatever was proposed experimentally is there in our syllabus. But even before that also there were many observations. So till 19th century, scientists used to have an observation that whatever matter you take, be it solid, liquid or gas, whatever matter you take, whether you take solid like this piece of duster, or liquid like a glass of water, or gases for that matter, whatever matter you take, if you try to break down that matter into smaller pieces, suppose if this duster is a part of matter, if I try to break down this duster into two pieces, you will get two, and the first piece into another two, the second piece into another two, continuously you do the same process, you will end up at a stage where you can no longer be able to break the piece of duster into further smaller particles. The smallest size of the duster you will finally end up with, that particle or that component is called as atom. Any matter be it solid, liquid or gas. If you try to break down matter into further smaller particles, you will reach a point where you can no longer break that into further smaller particles, and that point or that stage or that phase is called as atom. And that observation was, you cannot break atom into further smaller particles. Anything in the world or anything in the matter or anything in the universe can be broken down into smaller. I can break down this duster into many small particles. I can break down this marker into many small particles. I can break down water into smaller portions. I can break down gases into smaller portions. But what you cannot break down further is this thing, and it is atom. And for the same reason, you got the name atom from a Greek word called atomio. What does that mean? Atomio means which cannot be divisible. The undivisible particle of nature or matter is called as atomio, and it gives rise to the word atom. Okay? Everything in nature you can break down into two smaller particles or two smaller portions of that. Everything can be broken down into two smaller particles except atom, which is nothing but undivisible. This was the observation of scientists till 19th century. Everyone used to believe that you can break down everything except atom, therefore it is undivisible particle of matter. But an observation or a remarkable proposal is made by Dalton, which is called as Dalton's atomic theory. What he proposed was, atom can be divisible and it is having smaller particles called as subatomic particles. This proposal given by Dalton made a separate branch of chemistry or a fundamental branch of chemistry called atomic structure to arise. Until Dalton's atomic theory, no one has any doubt that something called atomic structure also exists. No one gave enough concentration on this topic called atomic structure. It was only because of Dalton's atomic theory that people came to know you have to study about atom. Atom also has its own structure, atom also has its own arrangement, atom also has smaller particles inside it which has to be studied. Therefore, let us give rise to a new concept called as atomic structure, which became a very first topic in our syllabus, and therefore based on this chapter only you will study all the remaining chapters of junior inter as well as in your senior inter. Okay? So, after Dalton's theory, the next question comes is, if atom can be divisible, what is there inside the atom which can be studied? What is there inside the atom which might be useful for us? And that question gave rise to a further new discovery called as atom has smaller particles called as subatomic particles. The smaller particles present inside the atom are called as subatomic particles. What are the three subatomic particles which is proved later, but for our convenience let us write now itself. The three subatomic particles are protons, neutrons and electrons. These three are the subatomic particles, and you cannot have an atom in which only proton or only neutron or only electron or any of the two exist. In every atom, all these three subatomic particles exist in coordination. Therefore, the question comes is, if they are present inside the atom, how will they work? How will they interact with each other? How are they not disturbing each other? How are they present in stability inside this very small undivisible, which was earlier thought to be undivisible, can accommodate all the three subatomic particles together. Therefore, Dalton's theory made way for a new discovery that atom has 3 subatomic particles inside it, which is proton, neutrons and electron. You just cannot say that proton, neutron, electrons are present inside the atom. You have to give a proof by doing an experimental observation. Therefore, the first scientist to experimentally prove that one of the subatomic particle called as electron exists inside the atom. Therefore, and then the next discovery came for protons and neutrons. That is the discovery of electrons. Let us study the discovery of each subatomic particle in order, starting with discovery of electron. Who was the scientist which gave enough concentration on electron was J.J. Thomson. Before starting this experiment, J.J. Thomson had an advantage of using Faraday's cathode ray discharge tube. J.J. Thomson started his experiment because of the help given by Faraday, because Faraday till then has already discovered electricity was already discovered, and it was Faraday only by using Faraday's law of electrolysis proved that electricity which is used has particle nature, means electricity is nothing but a group of particles passing through. That was already told by Faraday. If Faraday did not give Faraday's law of electrolysis, J.J. Thomson would not have thought that electron can be discovered using cathode ray discharge tube, right? So, based on this Faraday's law of electrolysis only, J.J. Thomson took a step of proving the discovery of electron by using the same cathode ray discharge tube which was used by Faraday. What is the common name of this cathode ray discharge tube is CRT tubes. Where do you find the applications of CRT tubes? In our television sets. Why so? Let us see in detail, right? By using this cathode ray discharge tube only, Faraday discovered by proving experimentally that electron exists inside the atom. How it is present, what is the nature of the electron, what is the mass of the electron, everything was discovered later on, right? So, this cathode ray discharge tube, let us see the diagram of cathode ray discharge tube. This is the original cathode ray discharge tube given by Faraday. The same cathode ray discharge tube was used by J.J. Thomson earlier, but after proving that electron is there, he made certain modifications in a stepwise manner to the same cathode ray tube, right? But what is the general cathode ray tube looks like is this way. This is how cathode ray discharge tube is connected to vacuum and all the gases are evacuated, right? This area is evacuated and it is present at very low pressure, right? You should operate this cathode ray tube at low pressure. And these two rods which you can see at either ends of this tube are nothing but electrodes. This is negatively charged electrode and the other is positively charged electrode. A glass tube which is sealed to vacuum is having two plates called as electrodes. One is negatively charged and the other is positively charged, right? The negatively charged electrode is called as cathode, which is not new to J.J. Thomson, it was already told by Faraday. And the positively charged electrode is called as anode, which is present on the other side. This is not yet modified. This is a simple diagram of cathode ray tubes, right? And it is connected to a very high voltage. Voltage should be high and pressure should be low. Why? Because it has some connotation with nature, because Faraday, when proposed electrolysis, J.J. Thomson observed how nature's thunderstorm starts from. It starts from a very high height, and at which pressure will be very low, right? Pressure will be very low. When thunder strikes, pressure will be low at atmosphere and voltage will be high. Applying the same, he took this cathode ray tube and have done the same, which is supplying high voltage and low pressure. When voltage starts, what happens is, from this negatively charged electrode, some rays are emitting and it is travelling towards cathode, towards anode, right? The moment you start giving voltage, cathode will start its work by emitting some rays. Starting from cathode, where will they go? They will go to the other electrode, which is nothing but anode. As cathode is negatively charged and anode is positively charged, the rays emitting from cathode, we will call it as cathode rays. As cathode is emitting that rays, we will call that ray also to be cathode rays. Where are they going? They are going towards anode. If they are negatively charged, they will definitely attract the other electrode, which is positive, right? So cathode rays starts from cathode and move towards anode, right? This is the simple cathode ray discharge tube. And can you see with your naked eye that some rays are passing from cathode towards anode? You cannot see. So how can J.J. Thomson just say, see, there are cathode rays going? No, because we cannot see. He has to prove that the cathode rays are really going from cathode to anode. If it cannot be seen, he has to take the other way around. Simply he cannot tell us that, see, the cathode rays are going, I can see. No, we cannot see. So what he has done? He has modified the same cathode ray tube. So this was the cathode ray tube exactly copied from Faraday. But this cathode ray tube cannot make you believe that cathode rays are really passing towards anode, because you cannot see. Then how can you prove? J.J. Thomson modified this cathode ray tubes by making a small perforation. Perforation means a small hole on the anode electrode. He has done some perforation on the anode plate and on the other side of the tube, on the other side, and inside of the other side of the tube is coated with a phosphorescent material or a fluorescent material. It is not coated entirely in the entire tube, it is just coated on the other side of the tube immediately beside anode, right? So this modification he has done on the cathode ray tube and then carried on the same experiment. What was the experiment? If you start giving voltage, what happens? Cathode emits cathode rays. Where will they go? They will go to anode. As there was no hole, cathode rays was striking on the anode and the story ends there itself. But as there are perforations in this modified cathode ray tube, was there any hole on the anode there? No. There is a hole in this modified cathode ray tube. This is modified cathode ray tube having a small hole on the anode. Now once you start the experiment, the same thing happens, and that is cathode starts emitting some rays which goes and strikes on the surface of anode. As there are small hole, the rays also enters into the small hole and comes on the other side of the tube, and now they will strike on this screen or this side of the tube. What is the material present on the inside of this screen? Is phosphorescent material or fluorescent material. If there was no phosphorescent material or fluorescent material, the rays would have entered this hole and strike on the screen, which you cannot see. But how can you see? To make us believe that the rays are really passing by, he made this modification, which is of zinc sulfide. which has phosphorescent nature. What is the speciality of phosphorescent nature? Whenever light rays strikes on phosphorescent screen or material or surface, it glitters or it lights or it brightens, right? So, now by starting this experiment, if you see any bright spots on this screen, what does that indicate? There might be some rays coming and falling on this screen. If there was no brightness, it would have been simply a screen having some coating without any brightness. If experiment is carried out, the rays would emit, it goes towards anode, enters through the hole and goes towards that screen, which gives small bright spots, or the screen glows at whichever point the rays strike. This observation can you see with your naked eye? Yes. Therefore, this is the proof that some rays are really emitting, which can be seen. From where are they originating? They are originating from a negatively charged electrode. Therefore, the rays must also have negative nature. The rays are called as cathode rays because they are emitting from cathode. Right? What is the nature of that rays? If they are starting from a negative electrode, their nature also has to be negatively charged. Right? Their nature also has to be negatively charged. And can you see their nature? Can you see their presence now? Yes, you can see by observing the brightness on the phosphorescent screen, right? And that negatively charged rays is nothing but it is originating because of voltage, which is electricity. As Faraday already told that electricity has particle nature, means small particles are there. That particles which are present inside the cathode rays are negative particles. Cathode rays has many negatively charged particles which are continuously striking on the anode, and that negatively charged particles are named as electrons. Right? What is the nature or what is the speciality of these electrons? Whatever electrode material you take, whether you take copper as the electrode or you take zinc as the electrode or you take platinum as the electrode, the nature of the electrons are independent of which type of electrodes you are taking. Whichever electrode you take, cathode rays or electrons are independent of the type of electrodes. Nature of electrons they are independent of electrode material. Whatever material you use to make the electrodes is irrelevant for the movement of cathode rays or the movement of electrode. And they are also independent of the nature of gases which are present inside the cathode ray tube. Whichever gases are present inside, they are independent of nature of gas. What does these two indicate? They indicate that every atom has a constituent particle which is called as electron, and you cannot have any atom without electron, right? Electrons are the fundamental or constituent particles which does not depend on all these factors or all these parameters. They are there in every atom, be it the smallest atom which is hydrogen or even the heavy metals. Every atom has these subatomic particles which does not depend on the size of the atom or the density of the atom or the nature of the gas. If it is a gas, they are there and they are negatively charged, and they will travel with this nature only, having a negatively charged nature, right? Now, this is the beginning of discovery of electron, and this is the proof that electrons are really present inside every atom. right? This is the proof that electrons are really present. How later at the end of this experiment, what do you got to know? That the nature of this electron is these two. You have to by that experiment you proposed that electrons are there, and to prove that experiment you have made this modification and got a conclusion that it is irrelevant of the electrode material, it is irrelevant of the nature of the gas. You also have to prove these two characteristics of electrons. To prove these two characteristics also, he made further modifications to the same already modified cathode ray tube. That was the simple cathode ray tube, to which he made a perforation, that is the first modification. And another modification he made is by placing electric field and magnetic field on the cathode ray tubes, right? From the discovery of electron till this, you can please copy the notes and we will further discuss later. Earlier we have seen first modification of a simple cathode ray tube, by which he proved that you can see the bright spot, which is nothing but electrons. So in further modification, what he has proved that what is the nature of the electron? What was the nature? It is independent of the material, it is independent of the nature of the gas. It has its own nature and it travels by its own nature. To prove that nature of electron, he made further modification to the same cathode ray tube. What is the further modification? To the same cathode ray tube having a small hole at anode, he has placed electric field perpendicular to the tube. If this is the cathode ray tube, electric field is perpendicular. Is it perpendicular to the electric field cathode ray tube? Yes, right? And magnetic field, which is also perpendicular to the same cathode ray tube. Is it perpendicular? Yes. Electric field which is perpendicular to the cathode ray tube, and magnetic field which is also perpendicular to the same cathode ray tube, and these two fields are perpendicular to each other. You, by seeing the diagram, you might be having difficulty in visualizing. So for that you imagine this to be cathode ray tube and this is electric field. Is it perpendicular? Yes. And this is magnetic field. Is it perpendicular to the electric field? Yes. Both the fields are perpendicular to each other and also to the tube. Now by starting the same experiment, what happens? You already know. If you start giving voltage, cathode emits some rays, travel towards anode, and through that small hole it enters into the anode and travel towards this screen, right? Unless you have whatever modifications you make, screen should be fluorescent or phosphorescent for you to be the result should be visible to you, right? So now if you start giving the voltage, cathode emits rays, enters into the hole of anode and comes out of the anode and strikes that screen. If your electric field and magnetic field is exactly the same, if the strength of the electric field and strength of the magnetic field is exactly the same, can one field overpower the other field if they are having the same strength? No. Both the fields are having the same strength and both are having exact equal capacity to deflect or to capture the electron. If electric field tries to capture the electron towards itself, magnetic field will take the electron away towards itself. Therefore, their fields are same and electron cannot deviate from its path towards any field if they are having the same strength. So what will the electron do? It will not go toward electric field, it will not go towards magnetic field. Where will it go? It will go exactly in the straight path, striking at the point B, and that is called as undeflected motion of the electron, because the fields are having the same strength and no one can take the electron towards themselves. Therefore, the electron travels exactly in the straight manner. But if you increase the strength of electric field, what happens? Electron migrate towards the electric field and it strikes at the point A. The path of the electron is deflected towards electric field or not? Yes, because electric field was having more strength, therefore electron was going towards electric field. If you increase the strength of magnetic field, the electron goes towards the whoever gave more field electron, more strength, the electron is going towards them and the path of the electron is deflected towards that field. Whichever field is having more strength, towards that field it deviates. So, by seeing these observations, if you see brightness at point A, that means because of magnetic field it went towards A. If you see brightness at point C, because of electric field it migrated towards C. If you see brightness at the center of the screen, that means both the fields are having same strength and the motion or the path of the electron depends on the strength of the magnetic field. That conclusion he gave by this modification. It was independent on these two. Then what does it depend on? It depends on the strength of the magnetic field. It is not dependent on which type of electrode you are using. It does not depend on which type of gases are present inside. It only depends on what field you are giving, what is the strength of that field. That is the nature of the electron. He proposed that electron exists. He proposed that you can see the electron through cathode rays. He proposed that the nature of the electron is by this cathode ray discharge tube. These three modifications made a conclusion that electrons is one of the fundamental subatomic particle inside the atom, which is present in each and every atom. It is having its own independent nature, right. For the same reason, J.J. Thomson was awarded a Nobel Prize for the discovery of electron. Here we stop and the continuation will be done in the next video. Okay, thank you.